if you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater, but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I'm Guna Mathivanan from Office's IAS Academy. In today's video, we are going to discuss about green hydrogen. First, let's understand about hydrogen. See, hydrogen is a colorless, odorless, tasteless, highly combustible gas. It is colorless, odorless, tasteless. It is lightest element and one of the most abundant element in this earth. One of the lightest as well as one of the most abundant element in the earth. Right? This hydrogen on combustion, unlike other hydrocarbons, this hydrogen on combustion will not release any carbon, rather the byproduct is going to be only water. That is, if I take a hydrocarbon, I take coal, I take methane, anything, I burn it on combustion, that is going to emit a lot of carbon. But hydrogen is also an excellent fuel. On combustion, it is going to give us only hydrogen, so it will be cleaner, no carbon emission at all. Right? Though hydrogen is one of the most abundant, the hydrogen is not available in elemental form. Hydrogen, it is not available in elemental form. The biggest source of hydrogen is water. So from water we can derive hydrogen. Water is the biggest source of hydrogen from which we can derive hydrogen. Other sources, other hydrocarbons, right? It contains hydrogen. Say for example, methane, CH4. It contains hydrogen from which we can derive. But the biggest source for hydrogen will be water. Right? So this hydrogen, based on the production process, this hydrogen is classified into gray hydrogen, black brown hydrogen, blue hydrogen, turquoise hydrogen, green hydrogen. So based on how you produce. So the most common way to produce hydrogen is catalytic steam reforming method. Catalytic steam reforming method. This is the most common method which is being used to commercially produce hydrogen. So in this catalytic steam reforming method, you can use methane or you can use coal. What we will do is, let's take, I am taking methane. I will subject this methane to steam in the presence of a catalyst. In the presence of a catalyst, I will subject the methane under steam, and that is going to give me hydrogen. Along with that, some carbon oxides will be produced. So from which I will derive hydrogen. So the most common commercial exploitative method available to produce hydrogen currently is catalytic steam reforming. When you use methane in this method, we will call this process as steam methane reforming. Steam methane reforming. See, the method is broadly called as catalytic steam reforming, but when you use methane, then we will call that method as steam methane reforming. This is the most commonly used method, but this method is highly polluting. It is highly polluting because to produce 1 kg of hydrogen, you will be producing at least 12 to 13 kgs of carbon. 1 kg to produce 1 kg of hydrogen, you will be producing 12 to 13 kg of carbon oxides, carbon dioxide, carbon in general. So this method is highly polluting. Right? So this hydrogen will be called as gray hydrogen. Instead of methane, if you use coal, then the hydrogen will be called as black hydrogen or brown hydrogen. So when you use methane and produce, you will refer it as gray hydrogen. When you use carbon and produce, coal and produce, then the hydrogen derived will be called as black or brown. It is called as black or brown because this process will release even more higher amount of carbon, right? Even more higher amount of carbons will be produced. That is why we are referring it as black or brown hydrogen. We have something called as turquoise hydrogen. Turquoise hydrogen. This turquoise hydrogen, through pyrolysis, we will be producing hydrogen. What is pyrolysis? So what we will do is we will take a hydrocarbon, let's say methane, we will take a hydrocarbon, we will heat it at a very low temperature in the absence of oxygen. That is pyrolysis. Let us say at a 500 degrees Celsius, we will heat it in the absence of oxygen. So methane is subjected to such higher temperature under the absence of oxygen. So that will produce syngas. Syngas is a combination of hydrogen plus carbon oxides. So from which also we can derive hydrogen. Such a hydrogen is called as turquoise hydrogen. Just see, this production process will not be asked in the exam. Just know these names: catalytic steam reforming, steam methane reforming, pyrolysis. Okay, through pyrolysis we produce turquoise hydrogen. Now what is green hydrogen? What is green hydrogen? So in this green hydrogen method, using electricity, that is, we will through electrolysis, we will produce hydrogen from water. Through electrolysis, we will produce hydrogen from water. So in this process, we will split the water. We will split the water using electricity. So we will split the water using electricity, and thus we will produce hydrogen. This production process will not emit any carbon. This alone is not sufficient to qualify it as green hydrogen. So I am using electricity to split the hydrogen, to split the water, right? This electricity should not be produced from thermal source. This electricity should not be produced from a polluting source. If this electricity is produced from some clean source, let's say solar. Assume solar electricity, solar power is used to split the water to produce hydrogen, then it will be called as green hydrogen. If wind power is used, if hydropower is used, if tidal power is used, if such power is used to produce if that power, the electricity produced from these sources, if that is used to split the water, then the outcome hydrogen will be called as green hydrogen. If you use electricity produced from thermal sources and then do electrolysis, that hydrogen will not be called as green hydrogen. This is general definition. Why it was in news? Ministry of New Renewables and Energy came with a new definition for green hydrogen in Indian context. That I will discuss slightly later. But this is how green hydrogen is being labeled. Indian Institute of Science recently, they derived a method to produce hydrogen from biomass. Right? So Indian Institute of Science indigenously they developed a method. So this biomass will be converted into syngas first. Syngas, I have already said, is a combination of hydrogen and carbon oxides. From this syngas, we will filter and we will bring hydrogen. So from biomass, we are generating hydrogen, which is a method indigenously developed by Indian Institute of Science. So I have explained about different hydrogen production process: steam methane reforming, that is the gray hydrogen or black hydrogen or brown hydrogen or turquoise hydrogen or green hydrogen. Now IISc, they are coming up with the hydrogen production process through biomass. Everything I have explained. Now this green hydrogen is very important. We will revisit to this green hydrogen. But Why hydrogen is significant for India?